right, another con support video. This one is on proportional relationships. So let's investigate. So it says a park has 3 meters tall tetherball pole and a 6.8 meter tall flagpole. The lengths of their shadows are proportional to their heights. Which of the following could be the lengths of the shadows? Okay, so what they're basically saying here is you've got a proportion, right? And so you've got the length of the pole as one part of your ratio is proportional. So the length of the shadow on top is proportional to the height of the poles. So basically the sun's in the same space relative to them. Okay, and it's got a tetherball pole and a flagpole. Okay, so this is the ratio we're looking at. And you know that ratio has to stay constant. So it says a park has 3 meter tall tetherball pole and a 6.8 meter tall flagpole. So basically, you're saying that there's a 3 meter tall tetherball pole. So that would be the height of the pole, 3. And a 6.8 meter tall flagpole. So that's 6.8. So the values on the top, right, have to correspond to these values on bottom. So you could set it up like this, where it's length of shadow over height of pole, where the top values are the lengths of the corresponding shadows, and the bottom values are the height of the poles. You could also set it up, if you wanted to, as the ratio of the height of the poles on the left and the length of the shadows on the right. So basically, the height of the poles on the left, which in this case might be like either 6.8 over 3, or you could do 3 over 6.8, it doesn't really matter. And then the corresponding length of the shadows. Okay, and just realize that the ratio needs to stay the same, right? So if it's 6.8 over 3, the length of the shadow should also be in that same relationship, right? 6.8 over 3, same ratio. So I think that's probably the easiest way to look at it here. So it says, which of the following could be the length of the shadows? And here it has the tetherball pole shadow and the flagpole shadow. Okay, so I think the easiest way to analyze it is to be using this model right here. Because in this model, you have the height of the poles compared to the length of shadows, and the ratios and the two have to stay the same. So the top one's the longer one. Obviously, the longer one is the flagpole. So you can think of this one as the flagpole. And then the bottom one's going to be the tetherball, right? So you got flagpole on top, tetherball on bottom. So everything related to the flagpole goes on top. Everything related to the tetherball pole goes on bottom. So the length, 6.8 to 3, and then the shadow, or the height of the poles, compared to the length of the shadows. So let's just test it out, right? Is 3.4 over 1.35 the same as 6.8 over 3? So if you grab a calculator, or they have this one here, I guess. There's this calculator, right? You grab this calculator, you just test it out. Is 3.4 divided by 1.35? Okay, that's 2.51, blah, 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 blah. Is that the same as what happens when you have 6.8 divided by 3? And you can see 6.8 divided by 3 is 2.26, so it's not the same. So A is eliminated. And we're looking for 2.6 repeating, basically, with the 6 repeating. Let's see what happens on the next one. 4.08 divided by 1.8. Oh, that looks good. That's the right one. So that one definitely works. Now, it says choose 2 answers, so one of them is going to be B. Let's check the other one. So 8.35 divided by 3.75. That one looks like it's not quite right. Let me see. 2.226. It's supposed to be 6.8 divided by 3. It's just supposed to be 1, 2. So 2.26, not 2.226. So this one's wrong. And then you've got 1.36. 1.36 divided by 0.6. That's 2.26 repeating, so that looks pretty good. And then the last one, which is probably not going to work because we already have 2, will be 4.8 divided by 2, and that's definitely not going to work. Okay, 2.4. So anyways, those are your 2 answers that you pick. That's how you do that. Okay. Next question. So let's see if I can move this around or whatever. All right. It says Sage's spaceship traveled 588 kilometers. Let's see. Sage's spaceship traveled 588 kilometers in 60 seconds. All right. So if you're thinking about kilometers per second, so we kilometers on top, seconds on bottom, it is 588 kilometers in only 60 seconds. Okay? So the kilometers per second, if you were to do the math on that, is going to be the unit rate, 588 divided by 60, and that's going to give you how many kilometers in every 1 second. So if you divide top and bottom by 60, you get what's called the unit rate, and we end up with the value of 9.8 kilometers for every 1 second, or 9.8 kilometers per second, which is the speed at which this spaceship is traveling. And then it says here, determine whether or not each spaceship trip below has the same speed as Sage's spaceship. Okay, so basically it's 2 kilometers divided by seconds, and we see if this all matches up. So let's investigate it. Is it 9.8? Is 441 divided by 45 equal to 9.8? Yes, has the same speed as Sage's spaceship. So the next one is 215 divided by 25. No, that's 8.6. That's a no. Then this one is going to be 649 divided by 110. That's 5.9. That's definitely a no. So the only one that's the same speed is the first one. That's it. All right, now we can erase this and do the next one. Let me erase this. Okay, so this one says Mile mixes 15 milliliters of bleach with 3.75 liters of water to make a sanitizing solution for daycare. The amounts of bleach and water have to be proportional when he makes sanitizing solutions. Which of the following could be combinations of volumes of bleach and water for Mile's sanitizing solution? So basically you want that ratio to stay the same. So you probably want to think about milliliters of bleach per liter of water, basically, right? So that means that you're going to want bleach on top and water on bottom. So I think it makes sense to do bleach on top, so liters of bleach on top, and how much water, sorry, not liters of bleach, milliliters of bleach. So you've got your milliliters of bleach on top, and you've got your amount of water in liters underneath, because you want the amount of bleach, milliliters of bleach per liter of water as the ratio that stays constant. So we can see here that it's 15 milliliters of bleach, 15 mLs, right, for every 3.75 liters of water. Okay, fair enough. So that's our ratio that we're looking for. So you're really looking for how many milliliters per liter of water. So you're going to divide top and bottom by 3.75. So when you do that, you get 15 divided by 3.75, and that is the ratio that we're looking for, and that's 4. So basically that means that what we're really saying here is we want ratios where it's 4 milliliters for every 1 liter of water. So 4 for every 1. When you're doing this one here, 12 milliliters for every 3, right? Is that the same as 4 for every 1? Well, let's investigate. So we got 4 over 1. Is that the same as 12 over 3? And the answer is yes. Right? Both of those are equal to 4. So that's a good one. I like that one. This one's 6 milliliters for every 1.5. Okay, 12 over 3, is that the same as 4 over 1? Yes. Is it the same as 6 over 1.5? Yes. That's the same because half of 12 is 6 and half of 3 is 1.5. So that works just fine. This one says 3 for every 0.75. So for every 0.75. Well, double 0.75, you get 1.5. Double 3, you get 6. So that's also the same. That's fine. So my guess is the other two don't work. Let's just make sure they don't work. Is 20 divided by 5.5 equal to 4? No. Is 11 divided by 3.75 equal to 4? No. So that's the answer. All right, and now we can do the next one. All right. It says the table shows a proportional relationship between milliliters of red paint and milliliters of yellow paint to make a certain shade of orange. So, okay, great. It doesn't really matter whether the milliliters or liters in this case. It's just the ratio of red to orange that matters, really, or red to yellow that matters. So what you're really looking at here is, since the units are the same, that's why it doesn't matter what the units are, both milliliters. So what you're looking at here is a ratio that's important. You want that ratio of red to yellow always to stay the same. So you want red on top, let's say yellow on bottom. It doesn't really matter which you choose as long as the ratio is constant. So that means we got 10.5 over 28. All right, so that would be that initial ratio there, right? 10.5 over 28. It says a row of values is missing in the table. Which of the following mixtures of paint could be used as the missing values in the table? All right. So basically what you're looking for is this ratio staying constant, first of all. Let's just investigate this. It should. 7.5 over 20 should be the same as 10.5 over 28. And 9 over 24 should also be the same as all of that. Let's see if all these are in fact the same the way we'd expect. So if we think about it, what do we get here? We get 10.5 divided by 28. That's going to be 0.375. 0.375. And then theoretically, 7.5 over 20 should be the same. So 7.5 divided by 20 should be the same. That's the same, 0.375, right? And obviously 9 over 24 then should be the same. And it is. I'm just going to prove it to you guys. 9 divided by 24 is the same, 0.375. So what you can see there is that no matter how you work with these ratios, the mixture is always staying the same. And the orange hue will always look the same because it's got the same proportion same portion of red and yellow mixed together as a ratio. So now we want to figure out which ones match that, right? So we're looking for the ones that match 3/8 basically, which is pretty straightforward. So you want the red divided by the yellow to be 3/8. So red 3 and the yellow 8, because that's really what 0.375 is. It's really 3 to 8, right? So that's the ratio you're looking for, 3/8, which is 0.75 or 0.375. So let's look at this one. So 1.25 and 5. All right, is that the same as 3 out of 8? Well, times top and bottom by 4, you're going to get 4 plus 1, which is 5 over 20. Is 5 over 20 the same as 3 over 8? No, that's eliminated. 1.5 over 4, that's 3 over 8. So that's fine. That will work. You just double both of them and you get 3 over 8. 8 over 3. No, you don't want 8 over 3. You want 3 over 8. That's wrong. This one's 7 over 16. That's not going to work because 7 is not going to correspond to the 3, right? It would be 3.5 over 8, which is not going to work because you cut both of these in half. You get 3.5 to 8. You want 3 to 8. So this one would have to be the one that works. Let's see if it does. Here you get 9 when you double the 4.5, and double this you get 24. So that's 9/24, which is the same as right here, 9/24. So that works just fine. So those are your two that you're going to use. All right, it says here triangle A has a height of 2.5 centimeters and base of 1.6 centimeters. The height of and base of the triangle B are proportional to the height and base of triangle A. Okay, so basically these dimensions are proportional to the dimensions of the other triangle. Which of the following could be the height and base of triangle B? Okay, so we just want the ratio to stay the same. So once again, let's investigate that. So let's just do it as A to B. It doesn't really matter. Actually, better yet, let's do it with just the heights and the base, right? So base to height is the ratio we're looking for here. So you could have base to height or height to base. It doesn't make a difference. I'm going to put base on top and height on bottom. Doesn't matter as long as the ratio stays the same. In fact, because it doesn't matter, I see they've got the height on top and the base on bottom. Let's just do it that way. It doesn't really matter. So I'm going to do it that way where it matches the question. So you got the height over the base. So we're going to look and see if that ratio stays constant. So it says triangle A has a height of 2.5 and a base of 1.6. So really what you're looking at here is 2.5 divided by 1.6. So 2.5 divided by 1.6 as your unit rate of that ratio. So you're looking at 1.5625. So that becomes 1.5625. Okay. So basically 1.6 times 1.5625 equals 2.5. And 2.5 divided by 1.6 is 1.5625. You just want these two values when you divide height by base to get 1.5625. Make sure it's constant. Let's see if it is. So 2.75 divided by 1.76. That's good. That works. Okay, the next one. 9.25 divided by 9.16. I mean, this is obvious. It doesn't work. Not going to work at all. The next one's going to be 3.2 divided by 5. And that's not going to work at all. And the next one is going to be 1.25 divided by 0.8. That's 1.5625. That's good. And this last one had better work, right? This is 3 answers. 2 divided by 1.28. And that works. Okay, so there's your answer. Just to make sure that that ratio stays constant. That's it. That's all there is to proportional relationships. Just relationships where the ratio stays constant. Natalie bought 8 glitter wands for $50. Determine whether or not each wand purchase below has the same price per wand as glitter wands. Okay, so once again, price per wand, that means price goes on top, wands goes on bottom. So price per wand, price over wands. We know that she bought 8 for 50, so it's $50 for 8 wands. What is the unit price? So that means the price per wand is going to be 50 divided by 8, which is $6.25 per wand. So your unit price is $6.25 per wand, okay? And that means that for every wand, you're going to pay $6.25. That means your multiplier is 6.25. So if you made an equation for it, it would look like that, and so on and so forth. Okay, great. Let's make sure we got the same ratio now. So we're looking at price per wand. So 20 divided by 4 is 5. That's a no. 37.5 divided by 6. Let's just check it out. 37.5 divided by 6. That's 6.25. Bada bing, bada boom. And 6.55 divided by 10 is 6.5. So that's not going to work. So that's a no. All right, let's do the next one. At East Middle School, there's 58 left-handed students and 609 right-handed students. The number of left-handed students, the left and right-handed students at West Junior High are proportional to the number at East Middle School. Okay, so that's great. Let's take a look at it. It says, which of the following could be the numbers of left-handed and right-handed students at West Junior High? Well, it says that it's 58 left-handed students to 609 right-handed students. So they have left on top and right-handed on bottom, so it doesn't really matter. Let's do that. So left on top, right-handed on bottom. The one that we're trying to match to is this one up here that has 58 for left-handed and 609 for right-handed. So that's the ratio we're trying to match. So what is 58 divided by 609? 58 divided by 609 is our constant that we're trying to achieve, that ratio, which is 0.095238 and then 0.95. So it looks like that's going to repeat. Anyways, so that's basically what you're talking about there, right? Let's see if we get that. So for this first one here, you've got 42 divided by 483, 0.08. It's not going to work. Okay, let's do the next one. 28 divided by 378. That's going to be 0.07. That's not going to work. The next one, you got 48 divided by 504. That's going to be 0.095238. Yep, and then repeat 0.95. So that is going to work. That's a good one. And that means the last one probably will work as well. That'd be 56 divided by 560. That doesn't look like it's going to work at all. That doesn't work. So which one did we mess up on? Let's see. It says choose two answers. Oh, there's one more down here. That's why there's an E. I knew there was something I'm missing there. So 330 divided by 315. This one should definitely work, right? Let's see if it does. 0.095238.095 and repeats. Okay, so that is correct. That's the next one, and now we're done. That's how you do it. Ratio just has to stay constant.